Okay, I hope it's recording because I don't. Okay, it is. The little symbol is on. All right, here we go. So a rational number, any number that can be written in fraction form, a ratio of two integers. So 3/5 is a ratio of two integers because it's a 3/5. 3 and 5 are integers. Negative 2, I don't know, ninths. That's a fraction. So it can be positive, it can be negative. 0 itself is a rational number. It can be written as 0 divided by 1. 5 is a rational number. It can be written as 5 divided by 1. But here are some other rational numbers. If you, in your calculator, do 1 divided by 3, what does it give you? If you do 1 divided by 3, what does your calculator give you? Uh-huh. And I just saw, when do we pick up Module 5? You can pick Module 5 up anytime. I've got the packets. Right now they're in my classroom. And after this class, I'm going to take the rest, or actually I think I'll take most of them down to the Mustang Center. No, not Mustang Center. What is it called? It kills me, the names. The old library. Mustang Commons, I'll leave them there in that foyer area. So what you want to be aware of is when you have a repeating decimal, 1/3 is 0.3, where 3 is repeating. Anytime you have a repeating issue where you've got a bar above, that can be written as a fraction. Now, do you need to know that? Probably not. That's not a huge deal right now. The main thing is it can be written in a fraction form, but also realize that numbers like just plain old 5, it is still a rational expression. So your job is to look at these and think, are these rational? Can they be written in a format of a ratio of two integers? So right now you're deciding which ones. So circle, go circle. Can it be written as a ratio of two integers? And if you make a mistake, it's perfectly fine. And do you realize that if you didn't make mistakes, then you didn't need the class in the first place? So it's inevitable. Besides, every time we do arithmetic, I don't know if you've noticed how many times I've made mistakes. But yeah, it just happens. We're human. So hopefully everyone saw that our nice whole numbers, 3, -5, those are rational numbers. 2/3, nice little fraction. Yes, that is a rational number. Yep, rational. Yep, rational. Can 2.7 be written as a fraction? Mm-hmm. How could it be written as a fraction? You could do 2 7/10. You could do 27/10. So if your decimal ends, you can always write it as a fraction. Now, what about the square root of 5? Is that something that we can actually write in a fraction form? That is not. That will not get circled. What about 2 cubed? What is 2 cubed? And so because it can be written in a fractional form, it is considered a rational number. What about 3 to the negative 3? Can be written as a fraction. Now, log base 2 of 8, take a moment. It's been a little while, but a logarithm is an exponent. Is there an exponent that you can put on 2 and get the number 8? That's actually equal to 3. So that means that because this can be written as a rational number, as a fraction. Now, this last one, you might not be sure of whether you can circle it or not. But there's one thing that I didn't say up here. Grab a wipe to make sure that so there's wipes over there. Wipe down desk and chair, and then grab also a packet that's right next to the wipes. So one thing I didn't say was a ratio of 2 integers as long as it isn't having a divided by 0. So I didn't actually finish that definition in order for you to be sure about this. It is not going to be circled. We don't divide by 0. All right, so if a rational number is something that can be written as a ratio of 2 nice numbers, integers are what we might say nice numbers, then a rational function is a fraction of 2 nice functions. What are considered nice? Polynomials. Woo! Who's not had enough of polynomials yet? Oh, wait, no one's raising their hand. Huh. Well, anyway, a rational function is a ratio of 2 polynomials. Provided that the denominator is not 0. So you have some expressions below, and you need to figure out which ones are rational functions. So take a look at those. It has to be specifically a ratio of 2 polynomials. For this first one, is that a ratio of 2 polynomials? That is a rational function. Next one, is that a ratio of 2 polynomials? A number by itself is still a polynomial as long as it's not 0. So that one, and then let me actually point you over to here. Whether you have just a number being the numerator or the denominator, either or, it is still considered a rational function. The only number you can't have is 0. If the numerator is 0, then it's just the function 0, which is almost pointless for us to even bother with anyway. Now, this next one, is a logarithm a polynomial? It's not. It's not. So it has to be specifically two polynomials. That one is not a rational function. What about this one that I just pointed to? Is that a fraction of two polynomials? It is. And then if I put a square root on something, it's no longer polynomial. So that one is not. Now, additionally, let's say I just wrote a polynomial. Is that considered a rational function? It is, because I can write it by putting it over 1. So I can write it as a fraction of two polynomials. So rational functions are all of our polynomials plus more. And we're going to, today is the algebra day, which for a lot of people, that's not the most pleasant day. But what I do is I try to go back and forth a little bit with the algebra and the graphing, because the algebra can get kind of mundane. So what we're going to do is we're going to first remember, how do we just add fractions? Just how do we do it? So when I'm adding fractions, first thing is I look at those denominators. Are they the same number? If they're not the same number, then I need to do what? Right. Now, when it comes to 3 and 7, do they have anything that can divide both of those numbers? So if you have two things where they have no common factor, you're just literally going to bring the other one in there. So the fraction on the left, you need to multiply its denominator by 7, the other denominator. But we don't want to change the value of the fraction, so we multiply the top and the bottom both by that 7. The fraction on the right, I look at the other denominator. I need to multiply by 3, but I don't want to change the fraction, so I multiply top and bottom by 3. Then I have 14 over 21 and 12 over 21, and now how do I add them? Who actually do I add together? So I add the 14 and the 12. The numerators get added, but I keep the denominator as it is. Now, 26 over 21. When the numerator is larger, we call it improper. And I'm going to not push you to have to write your rational functions in a proper form. There will be a time when I have you see how to do that, so that you can then decide if you want to go through the trouble of writing it in that form and how it's useful. But I'm not going to force you to have to write them in proper form just for no reason at all. It will be for a reason when we do. All right, now let's look at these and let's add them. You want to realize that this addition cannot be broken. This entire parentheses is one factor. You don't get to separate the x and the 1. X plus 3, don't get to separate that addition either. What you want to see is x plus 1 and x plus 3 are two linears. And you know how you might write two linears together are the factoring that maybe you had done. So these are two factors that are just completely different. Just like the 3 and the 7 were just completely different numbers. So when that is your situation, you're literally just going to multiply by the other's denominator. So you're going to multiply the numerator and the denominator by exactly the same thing, so you don't change that rational function. You need the other denominator, so multiply top and bottom by x plus 3. For the fraction on the right, you need to multiply the denominator by the other fraction's denominator, but not change anything about the algebra. So multiply top and bottom by exactly the same thing for each individual fraction. Okay, wake up. There we go. So what I have is the fraction on the left is 3 parentheses times x plus 3. And by the way, you can do this in fewer steps than I'm doing. I just want to not lose anyone on the way. The denominator is x plus 3 times x plus 1. Second fraction, I have a 4x multiplied by a parentheses of x plus 1. Now it's your choice as to whether you want to deal with the distribution of the 3 and the distribution of the 4x first and then add them together. But ultimately, you do have to do that distribution before this addition is actually able to do its thing. So I am going to do 3 times x plus 3 times 3. And then I'm going to distribute 4x times x plus 4x times 1. Now, it's going to be a little bit easier for the next step. Once the denominators are identical, you're able to just keep that denominator and add the numerators. So 3x plus 9 is going to add with 4x squared plus 4x, but the denominator that is shared is just kept. Now, how do we add polynomials in that numerator? Uh-huh. Ah. Oh my goodness, it's hard to hear. So nah, I still can't hear. Adding the, like, I can't quite hear you, but I think you're saying. I know. It's really fun to hear people with masks on, isn't it? Have you tried to order things and actually, do any of you have a job where you have to understand what people are saying through their mask? How hard is it? It can be really difficult. Anyway, we're adding our like terms. I think that might be what you were saying. Yeah. So my like terms are, I have 2 terms that both have an x, but nothing else is going to add together. So I have a 4x squared If I write my numerator in standard polynomial form, I put the largest exponent first, then 3x plus 4x makes 7x, and then I have a lone constant term. Technically, the order of that addition doesn't matter. And I am going to tell you this. You are simplified when, in one combination or another, your numerator and denominator are either fully factored or fully expanded. So if you're in expanded form, then your like terms have been added together. If you're in factored form, then you have factored as much as possible. But I'm not going to expect you to factor this numerator. You can leave it in its expanded form. The only issue you could possibly run into is sometimes when you do factor that quadratic, you end up having either an x plus 3 or an x plus 1 that will cancel with one of those on the bottom. Now, if you look at that horrible mess, do you think that either one of those two is going to be a factor? And is there a quick way to tell? So remembering some things from polynomials, if x plus 3 is a factor, then when I plug negative 3 into the polynomial, I get 0. Will I get 0 if I replace these x's with negative 3? Can you see that that is not going to happen? Don't even need to think about it too hard. Then x plus 1, negative 1 makes x plus 1 0. If I plug a negative 1 into these x's, do I get 0? So that's a quick check so that you don't need to bother trying to factor. You're good. So look at the zeros of those factors and just make sure that they don't make the other side of the fraction equal 0. Biggest thing is just knowing how to get to this point. If it confuses you, what I just talked about with making sure that you can't factor and cancel more, it's not that big of a deal in the big picture. The biggest thing is just, do you understand how to do the addition and subtraction? So here we go. Number 4, look at the denominators. They aren't the same denominator, but do you see that both of them are divisible by 2? So you don't want to waste your time making numbers bigger than you need them to be. If they're bigger, think of the arithmetic. Worse. So if they're both divisible by 2, take a look at what they are. 8 is 2 times 4. 6 is 2 times 3. What you can actually do is just look at the two denominators as neighbors. And have you heard the, keeping up with the Joneses? Have you heard that phrase? That's the idea of, oh my gosh, my neighbor just got this brand new car. I need to get one too. My neighbor just redid their front yard and it's nicely landscaped. I better get mine done too, because otherwise I'm just failing. Look at it that way with these two. So one denominator has 2 times 4. The other denominator has 2 times 3. Both of them have 2's already. Don't make your life difficult and cause them to do more than they need to do to keep up with the other. So look at the first denominator, 2 times 4. What does the other fraction have that it does not have yet? A 3. So that's what you need to multiply the denominator by. And if you multiply the denominator by that, you have to also multiply the numerator by that. Then the denominator of 2 times 3, what extra does the other denominator have that it doesn't yet have? That 4. So it's going to keep up by multiplying its denominator by that 4 that it doesn't have, and multiply the top by the same thing. And now 3 times 3 gives us 9 in the denominator. I have 3 times 8, 24. Second fraction, 5 times 4. And then 6 times 4 is also 24. Add the numerators, keep the denominator. And if you went with the least common denominator, your fraction doesn't need to be simplified further. And again, I'm not going to force you to write your fractions in proper form. Because let me tell you that in future math classes, you actually want to leave them in this form. So, yeah. Really the reason for needing to write it in proper form is so you understand what number you're dealing with. But if you want to understand what number you're dealing with, you're probably having a calculator next to you, and you can just let the calculator tell you the size of the number. All right, now let's look at this one. So that keeping up with the Joneses thing. Look at the first denominator. I'm going to highlight it. What does the other denominator have that it does not have? So it needs to keep up with its neighbor and multiply by an extra x minus 1, but I want to not change the fraction. So I multiply the top and the bottom by that same thing. Then look at the second denominator and say, what does that other yellow highlighted fraction have that I don't have yet? And what would that be? What does the other denominator have that this blue one doesn't? You see it probably, I just don't want to say it. There we go, I see it online. Multiplying by x plus 2. Now, the first numerator, you have a 2x that needs to multiply with a parentheses x minus 1. And again, you can do this in fewer steps if you see fewer steps to do. I'm going to do this slowly to make sure I don't lose anyone. For the second fraction, I have a 4x times a parentheses x plus 2. And I want to take those numerators and get them ready to add together. I need to distribute the 2x over the parentheses, and I need to distribute the 4x over the parentheses. Two x times x gives me 2x squared. 2x times -1 gives me -2x. I'm going to keep the denominator. Who's having fun? Ha ha ha. For some people, there are a lot of people that really find algebra fun to do. And I want you to do your algebra, as long as you're doing it correctly, you can show however many steps in whatever order makes sense to you. I want you to enjoy your algebra, not feel like you have to put it out a certain way. Huh? Oh, headache. Oh, darn headaches. And anyway, all right. 4x multiplied by x, and then 4x multiplied by 2, and keep the denominator. And now those numerators are ready. Notice the denominators are exactly the same 3 factors. If one of them had a different order of those 3 factors, it wouldn't matter. Order of multiplication does not matter. So when I add my fractions, I keep the denominator that is in common, and I add the numerators together. And again, I'm going to do this in more steps. If you want to do fewer steps, you can. Now I'm looking for like terms. I see an x squared going on. So these are like terms. I see lone x with another lone x. So these are also like terms. So 2x squared plus 4x squared. 2 plus 4 of the x squareds. Negative 2x's plus 8x's. Negative 2 plus 8 gives me 6 of those x's. Now, if there's nothing else that can cancel, if that numerator cannot be factored in a way where a factor can cancel, I'm okay with you leaving your answer this way. But let's check. That numerator is actually not too bad to factor. Do you see that there's something in common? That first rule of factoring is what's in common that can factor out. What do you see? What's in common? Mm-hmm. And everyone online sees that, a 6 and an x. Then what's left over? And you got it. Now, is x plus 1 one of the denominator factors? There's an x minus 1, but not an x plus 1. So you actually don't have anything that will cancel. And I want to tell you what that means. That means this is a correct answer, but it also means I will accept this as simplified as well. Both of those are perfectly good, legitimate answers. The only reason that I factored was to check and make sure that I didn't end up with something that would end up canceling. Okay, woo, that was fun. No, yes. If we're doing addition, you will have to factor them. Those denominators are going to be in factored form in order to do the addition. Yes. Yeah. So When it comes to addition, when you deal with addition or subtraction, you do want your denominator factored. And if there are factors in common, you don't want to multiply by that more than you need to. So you're looking for that least common denominator, and that's a... No, the numerators don't need to be factored. Very good question. You only factor the denominators because you're trying to see if you can bring in less. Because every time you multiply by a larger polynomial, just how much difference that makes. And that also means more work at the end when you simplify. And we want to avoid more than we need to. So that's dealing with addition. Then we've got multiplication and division. So let's start off with, do you remember how to multiply fractions with 5a? Just regular old fractions. I'm assuming some of you are remembering. You get to flat out multiply across the top and multiply across the bottom. Just so 3 times 5, 8 times 6. But then you're looking for, are there numbers that can divide both the top and the bottom? And as I say that, does anyone see something that you might have started with to make your life better? Yeah. Now let me point out that I multiply the two numerators 3 times 5. I multiply the two denominators 8 times 6. You can take that, you've got a 3 here, and then a 6 here. They weren't in the same fraction to begin with, but when you're multiplying, everything that's multiplying on top is the numerator. Everything multiplying on the bottom is the denominator. Can you simplify 3 over 6? So you can save yourself a little bit of multiplication pain if you see that. And that also saves you the pain of trying to simplify from this step. So when I look at the fact that I was able to cancel some stuff, I now have 1 times 5 over 8 times 2. Easier to multiply. And then this one, you have to, this is not considered simplified. You have to divide by 3 to numerator and denominator. You have to realize to divide by 3 to get the same answer. So, what's the moral of the story? Look for common factors. And it just is anybody in a numerator can cancel with anybody in a denominator if you are multiplying. So, over here, you know what I always did? This is what I always did. Are you watching? Are you watching? I was just like, this is silly. Just make it a big giant bar because that's all it is. So let me show you again. I've got a multiplication of 2 fractions. Anytime I see multiplication of 2 fractions, I just make this a bigger bar, understanding that those numerators multiply, those denominators multiply. Now, do you see factors that can cancel? You have, in common, x minus 2 on the top and an x minus 2 on the bottom. Woo! I love canceling. Anything else in common? So, what's the moral of this story? Multiplying fractions, so much more enjoyable than adding. And you can leave your answer in factored form. Now, because I have two of the same thing, it should be written as x plus 2 quantity squared, but I'm not going to mark you down on a test if you write two multiplications of x plus 2. It means the same thing. And there you go. Now, a little bit more. Do you remember how to deal with division? And I want to show you something in case you don't remember. Or maybe you remember, but you don't get why. 3/8 divided by 5/6 is the same thing as this. And you're not going to need to do this. I just want to show you. I've got a top fraction and a bottom fraction. If I multiply both by the same thing, I'm not changing that. If I multiply both by 6/5, do you see that down here, that just turns into 1? So that's why when you see division, you change it to multiply by the reciprocal. So we're going to rewrite. And then my recommendation is see what can cancel before going forward. So big giant bar. Is there anything that will divide? Yep. And do you guys online see something you can divide? Are we all awake? It's tough. Some of you are probably like, your sleep schedule has shifted. So I can divide the 6 by a 2. I can divide the 8 by a 2. And you can only cancel something in the numerator with something in the denominator, so nothing more can be done. Now I have less to deal with. 3 times 3, 4 times 5, done. So with 6b, we're really just going to do the same thing that we did in 5b, except we've got to turn it into multiplication first. And this is kind because it's already factored. Your homework won't be quite as kind. You're going to have to do some factoring in your homework. So I don't know about you, but I don't like writing more than I need to, so I'm going to do this. Do you guys do that too? That way I didn't have to rewrite that first fraction. Now, everything is factored already for you. Know that in your homework, you're going to need to do some factoring and then see what cancels. So do you see between the numerator, you've got 1, 2, 3, 4 different factors in the numerator. In the denominator, you have 1, 2 different factors. Are any of them in common? So it's rah! And I'm left over with an x plus 1, an x minus 2, a second x minus 2, and in the denominator an x plus 5. So that is addition, subtraction, multiplication, division. Now you have a homework assignment, and let me point out to you, you've got some addition, subtraction, more addition, subtraction, but do you see that this time things aren't factored for you. But hey, we've got 10 minutes to get started on the homework together. So realize that you need to do an extra step of, if you see a polynomial that can be factored, factor it. And then multiplication, division, you're going to have to factor a whole bunch. The factoring is really, really important for you to practice. I'm going to stop recording with the lesson. And